Good morning, everyone. Welcome to our day 3 of data analysis with Python. And today we are going to be conducting a case study. So we are going to be applying some of what we have learned in the previous classes on a real life data set. So today we are going to be analyzing motorcycle sales data. So this is a particular sales data for a motorcycle, for an organization that deals with motorcycle parts. So I want to make some insights based on this particular data, and also how we can use some of these Python functions, operations to analyze this data. So you can see, first of all, we have our data. So if you go back to our Jupyter home, so you can see our data here says .csv. So this is currently on my file. This is the file which I'm on now, case study copy.ipymb. So this is a Jupyter notebook file, and this is a CSV file. It's called the comma separated value. So a CSV file. So if you actually open it now, you can see it is separated by commas. So you can see we have the date, warehouse, clients type, products line, quantity, units, price, total, and payment. So these are the headings, and these are what the values that followed. So they are all separated by what, comma. So the next row is going to be on the next line. So this is why it is called a CSV file. So now, some of the libraries we are going to be working with is the pandas, the numpy, and also the matplotlib. So if you don't have it installed, the best way for you to install it is to go to your Jupyter and click on new, then you open your terminal. So by the time you open your terminal, you can be able to install these libraries on Windows PowerShell. So if you want to install it, which I already explained in the day 1 class, you use the command conda install numpy. So you run it. So I already have it installed on my local machine, which means I'm not going to run it. But this is the code which you are going to use to run it. So you just click enter on your keyboard, and it is going to run it for you. So conda install numpy will install numpy. Why, if you want to install pandas, use conda install pandas. Conda install pandas is going to be installing the pandas library for you. Why conda install matplotlib will be installing the matplotlib library for you. So this is just the way I'm going to work. This is the code or the command I'm going to be using to install any library you have. So conda install, then followed by the package or library name. So now, if you have all of this installed, then we can now go back to our documents. So first of all, now, if you want to now load a particular library, so you have already installed it on your local machine. So what if you want to now use this library? So this is where you now use the command import numpy as np. So you are importing the numpy library as np. So you are going to be using this np to be referring to any function that was created inside this particular library, that is numpy. The same thing also applies if you have pandas. You are going to be using import pandas as PD. So the import pandas as PD allows you to use the functions or access the functions in the pandas library. So anytime you want to refer to these functions, you use the keyword PD. You use the for numpy, you use np. And sometimes it's not necessarily it's always np. You can change it to anything you have, but most of the time, the conventional way is to use np for numpy and pandas as PD. You can use n for numpy. You can be using L all through your documents, or use p for pandas as p. But conventionally, it is np that is used for numpy and pd is used for pandas. So this is we are going to be running this particular one. So you can see now I've already run it. Has shown that our cell has been this cell has already run. It has been run for 7 times. So I can still run it again now. It's still showing the 8th time I'm running this cell. So which means that we already have these particular libraries loaded in this particular Jupyter notebook. So now you can also see something now, matplotlib inline. So what this actually refers to is that matplotlib inline allows you to upload to show on your Jupyter notebook, which I'm going to see later on when we start doing some visualization. Because if you don't have this matplotlib inline run, then it's likely that your plot that you'll be plotting is going to be opening on a new tab on your browser. So instead of you to have your plots in your Jupyter notebook so that I can share it with others, it's going to be opening in a new tab on your browser. So that is why you need to have this code run. This is the %matplotlib then inline code. So it allows you plots to be displayed on your Jupyter notebook and not on a new window. So now we're going to be reading in our data. So the command for reading in data is pd.read CSV. So this is actually methods. So you can see now, I cannot be able to access this function now. Imagine read your CSV now. So imagine I just want to use read CSV to access sales.csv. So you can see that this tells me that the name read CSV is not defined. So what this actually refers to is that there is no function called read CSV. And this is because by default, Python, there's no Python functions by default of what read CSV. But this read CSV actually belongs to the pandas. So that's why I have to use the the PD. So I have to use the PD method. So I'm going to use the PD. I'm going to use the read CSV method, on the PD keyword. So this will allow me to be able to access the read CSV function, which is stored in the pandas library. So when I now run this now, you can now see I have my data. So this is the data set we're going to be working with. You can see the dates. You can see the warehouse, the details of the warehouse. You can see client type. You can see product line, the quantity of item bought, the unit price of each item, and the total price, which is actually what's unit price times what's quantity. Then also the payment method. Was it paid by credit card, cash, or transfer? So if you notice now, each row takes a particular transaction that was made. So each transaction now, which is on the first, so this is on the 1st of June now, 2021. Then a transaction was made at the central warehouse by a retail client. And the product line of the item bought was miscellaneous. And the quantity of that item was 8. The unit price was 16.85. And the total amount that was made was 134.83. While the payment was paid through credit card. Same thing also you can follow for this other one, you can follow this other one. And I told you that indexing in Python starts from 0. So you can see now the default indexing is starting from 0 to, you can see it is from 0 to 999. So which means we have about 1,000 rows in this place, but the indexing starts from 1. That was why the indexing of the last row is 999. It's always very important to take note that indexing starts from 0 and not 1 in Python. So as to not to mix it up, because most of us are used to indexing starting from 1. But currently now, I only run this here now, pd.readcsv. This is my file path. So this is where my file was stored. Sales.csv was stored in, it's actually stored in this place. So you can see my sales.csv here. So I have to give the file path here. So since it is already in the folder where my Jupyter notebook is, I'm just going to give only the name of this particular file, which is sales.csv. Assuming my file was now motorcycle sales, I'm going to be giving motorcycle sales.csv. So the name of your file is going to be followed here. But that should only be the case if your data is in the same folder as your Jupyter notebook. Else you need to put the folder name. So if I'm having a folder now called data, I'm going to be using data, then this sign. So this will be able to allow me to be able to access the file in this particular folder. But because my data and my Jupyter notebook are in the same folder, this is the reason why I'm just going to only give the name and which allow me to be able to access particular data. But currently now, I've only loaded the data. I cannot work with it because I haven't stored this data in a variable. So this is why you need to be able to store this particular data in a variable. So now I'm going to be calling my data sales. So I'm going to call it sales. So now this is my data, which the pandas library has read in for me. Then I'll now be storing it in sales. Why I'm storing it in variable sales so that I can be able to now make use of it anywhere in my Jupyter notebook. I can be able to now access this particular data. So you can see earlier on when we viewed sales. So when we viewed sales earlier on, you can see it truncated. It only gave us the first 5 rows and the bottom 5 rows. So you can see that we are not seeing other rows to in between. So this is because the data is large. So it's not going to, by default, it's going to only show the top 5 and bottom 5. So it's not going to show us all our data. So most of the times, you're going to be noticing something like this. So if your data is big or it is more than 10 rows, then it's likely that you are not going to be seeing all your data. You'll only be seeing the view of the first 5 and also the view of the bottom 5. So now, what if you now want to just check you want to check the upper part of your data now. So I just want to check the upper, that's the top 5 rows of my data. So this is where I'm going to be using the sales head method. So this sales.head allows you to be able to access your first 5 rows. So you can see your first 5 rows. So if I say sales.head now, I'm going to be seeing my first 5 rows. You can see that my first 5 rows is, you can see what I'm having now. These are my first 5 rows. So what if I now give something like 10 now? So it actually takes an argument. So anytime any value that a function takes is called an argument. So this is a method because we can apply a method to a variable, or you can apply to a variable, or you can apply to an object. So this can only work on the sales. You cannot have edge on a particular data type. So if you're having a data, then the head, you can use the head method on it. So which means that this particular method doesn't work in all objects or all variables. It only works in specific variables. So now the argument it takes by default is going to be what? It's going to be 5. So by default, and I can see it's only showing us the top 5 rows. But if you can also give your own value, and I can give 10 now, It's going to show me the what top 10 rows. You can see. What if I give 20? So you can see I have what my top 20 rows. So this is what the this is what the head method does. So sales.head, or the name of your data, then .head. So the argument it takes depends on how many number of rows you want it to view. Most of the time, if you do not put any value, it's going to be giving you just only 5 rows. Now, also, what if you want to now check for the bottom rows? So this is where you now use the word sales.tail. So you can see sales.tail shows you what your bottom 5 rows. And also, just like the head method, also, if I'm to give the value of 20, it's going to show you my bottom the bottom 20 rows in my data set. So sales.head and sales.tail allows you to get an overview of your data. But most of the times you're going to be using the sales.head. So now what if I want to check now the data types of I want to check the data types of each particular column, because one thing with a data set is that a data set is a combination of various columns. So let's go back to it now. A data set is a combination of various columns. You can see it now. Why these columns now? Each column must have all the values under each column. It must be of the same data type. So we cannot have 2 data types under a particular column. So though the columns may be of different data type, like in this scenario, the payment is a text, the total is a numeric value, the quantity numeric. You can see product line is also a text, but you cannot be having a numeric value here and also be having a text under the same column. So a data set, anytime you're reading a data set, is usually made of, or a data frame is usually made of various columns. And these various columns can be of different data types, but each column must be made up of the same data type. Each column has to be made up of the same data type. So now let's check the data types of this particular column now. So I'm going to be running sales.dtypes. So you can see sales.dtypes here now. This gives data types of each particular. So you can see the date is recorded as objects, the warehouse is also objects. So the objects actually covers either dates or text at times. So the general, we can just give it a general data type of object. While we have quantity, which is integer, unit price, which is float, total is also float, and we have payments also, which is object. So now this allows you to see the data types of your, allows you to see the data types of each particular column you have on your data frame. So now, how do you also know the number of rows and columns you have in the data set now? So you have a data frame now. You want to know how many rows do you have or how many columns you have. So this is where you now use the shape. You can see this shape method you have. So you are going to be applying the shape method on your data. So if I run this now, you can see I have 1,000 rows. So the rows is going to be the first, while the columns is going to be the second. So we have 1,000 rows and 8 columns. So you can see our rows and you can see our columns. So this is what the shape allows you to do, to get the dimension of your data. So you want to know the number of rows you have and you want to know the number of columns you have. So what if you also want to get your column names? If you're having a very wide data, let's say data having 40 columns, and you want to get the column names of this particular data. So instead of just running your sales data and viewing it manually, you can just use the sales.columns. So this columns method allows you to be able to see your column names. So it's going to be recording your column names in a list. So we talked about list. You can see it. It's starting with a square bracket. We talked about list yesterday. So you can see it sales.columns. So let's say now I apply a square bracket now. Let's say 2. You can see now I can access the items in this particular, which means I can almost store it as a variable. So now this sales.columns now actually stores the names of each column in a list. And you can access the items in this list using your in your square brackets indexing, which I just did now, which means you can even use this particular sales.columns and create a variable out of it. So I can just call it now my column names. I can just call it column names. So it's going to be equal to sales.columns. So you can see it now. So where here I can now say, okay, what is the third item under column names, which is what? That is index of 2, third item. Remember, indexing starts from 0. So you can see the third item in my list is client type. Okay, now from the third item now to the 6th item now. So from the third item now to the 6th item is what? So you can see from the third item now to the 6th item. So it's not actually going to show you. I explained this earlier yesterday. The upper bound is not going to be shown anytime you are using your range. You are indexing a range. So the upper bound is not going, the value of the upper bound will not be shown. If you want the value of your upper bound to be shown, you need to give the value after the, you need to give the indexing of the value after the upper bound, which means I can give 8 now, and I can get the value of my upper bound, which is what? Payment. So this is how you can get the column names in your data set. You want to mix use of column names in your data set. So now what if I want to get the first 5 rows now of a particular column? So now, for my client type now, I want to now get the first 5 rows of a client type. Okay, let's say now for under payments now, I want to get the first 5 rows. So now, just like other data structures too, a data frame too, you can subset or what, index a data frame by its column names. So I explained something similar to this in dictionaries, where you use the keys to be able to what, get the value of that particular dictionary. That's inside a dictionary, you want to get a particular value by its what, key. So currently now under says I can access a column by their names using the square bracket. So now when I give my quotations now, I want to access payments now. So when I run it, you see, I'm going to get the result of what? All the items under payments. I think you can see it now. And under this also too, I can also apply another square bracket on it to what? Access a specific row. So if I'm interested in only what? Row 1 to row 6, to row 5, I can just see. So row 1 to row 5 is going to be what? 0 to what? 0 to 6. So you can see it. Row 1 to row 5 should be 0 to 5. So that you can see this is row 1 and this is what? Row 5. Row 1 is having indexing of 0 and row 5 is having indexing of 4. So now I can now access what? Now what I did now is that I already have my sales payments. And now I want to access only the what? First 5 rows, which is what? 0 to 5. You can see that I've already accessed it. What if I want to access the 7th to the 10th? I want to access now the 7th now to the 10th. So the 7th row is going to be carrying indexing of 6. Why the 10th now? We want the 10th to be covered. So we're going to be giving what? We're going to give that's going to give 11, I think. So we're going to give 11. So you can see now 6 to 10. So now this is actually our 7th row, but indexing of 6. So these are 7th rows and indexing of 6. These are 11th rows and indexing of 10. So this is how we are able to access it. So this is how you can use the square brackets to access or to subset your data set. So you just want to subset, you don't want to work with all your columns, or you don't want to work with all your data sets. So you can just use this particular subsetting. So what if I do like this now? I apply just 2. I apply payment and I also apply, let's say, clients type. I think. Okay, sorry. Okay, let me see the column name. Okay. Okay, that will bring us another function later on, which we are going to be using to subset more than one column name. So for now, we just stick to the square brackets using the, we are going to stick to the square brackets for subsetting only just one column. So now, so we want to index the column of the first 10 rows and the first 3 columns now. So this brings us now to the ilog function. So the ilog functions allows you to be able to index or subsets from your data frame based on their index values. So now you see, if I want to now get my first 10 rows, so I'm going to be using the sales.ilog. So the ilog method now, I'm going to be giving my, first of all, now let me just say I just want to subset row 1. So I'm going to be giving row 1 is going to be 0. Then I now want to also subset column 2. So you can see it now, which is what's written. Okay, what if I now want to subset all the columns? I want to subset all the rows, but just only what's column 2. Because column 2 now, if you go back to it, now you can see that column 2 is client type. So you just go back to it and now run this. So you can see now, this is going to give us all our values in the rows, but only what's for column 2. So from the name ilog, it only uses what indexing. You cannot give the name of your value. So that is why we have 2 of this method. We have ilog and we have log. Most of the time, we're going to be using the log method. So the log method allows you to now subset your data frame based on their names. So now, instead of using their index, now you are going to be now using the names, which is more easier. So now I can just subset all my rows by using the column. So when you give the value of the column first, it's going to give you all your rows. Then what am I going to give next? I'm going to be giving my what? I'm going to, let's say first of all, now I'm going to be giving one column, client type. So you can see now I'm giving a single column now, client type. You can see it. And I can also give what payments. I'll get all the value of under what payments. So currently now I'm subsetting what? Only the column of payments, but all my rows. So what of it? I just want only row 1 to 5. You can just see row 1 to 5 is going to be 0 to 4. You can see row 1 to 5 under payments alone. But what if I want all the columns, but only for row what? 1 to 5. I'm just going to remove that column and I give an error and just put the column. So this column covers all the columns. The same thing also applies here. If you give column, it covers all the rows. So let's just try something interesting and give column on both sides. You can see we have our full data. So the column covers all the rows, while the column covers all the column on the right hand side covers all the columns. So now I can now give this, let's say row 1 to 5 now, going to be 0 to 5. 0 to 5. So you can see now row 1 to 6 is gives row 1 to 6 now. We have all the values of row 1 to 6. And you can see the column now is already covered for all these what column names. So what if I just want only warehouse now to quantity? I want warehouse to quantity now. So I can just say, I can just create a new list now and say warehouse, then comma, client type, then comma, product line, then comma, quantity, then comma, okay, let's just stop our quantity around this now. Sorry, I think we made a mistake here. So you can see it now. First of all, we have to give a list of all the column names which we want. So I'm going to be storing all of them in a list. So you can see it here. Warehouse, client type, product line, and quantity. So it's going to give us all of this. I can also try something like this. Let's see. Okay. Sorry. Okay, so now by typing all the what column names now, warehouse, client type, product line, and quantity, we have already put all of these values in a list. Then you can now see that we're able to what subset for all these columns in this particular data frame. So this is how you can just work with subsets of your data. Most of the time when you have long data sets or with long column names, you're not going to be making use of all the columns. This I can just fix all the columns and I can actually create a variable out of it. So I can just call this subset. Let's call it subsets. And when I run subset here, so you can see now I already have a variable, I already have a what data frame created called what subset. So you can now work with also this data as a whole. So this is different between the iLog and the log. So the key difference is that the iLog uses what indexing. So the column, the range I was trying to give in earlier on doesn't work with the column names. It actually works with the index. So if you want to give a range now, you're going to be using the index. So this is 0 to 3. So from 0, now this one, I want only what the row of 0, the row with index 0 to row with index 10, then what column with index 0 and column with index 3. So when I run this is what I'm going to have. So you use the column when you want to select a range of columns, but this only works in the iLog. While the log only carries what the log method only carries what column names. So now, what if I want to order the data now? So currently now, let's just view our data now. Sales. So this is our data currently now, and I want to order it now. I want to order it by total. So the highest total should be showing, then followed by the lower total. So it's going to be going in a descending order. So how do I do that now? So this is what I'm now going to. I'm now going to say sales. I will now use the what method sort values. So just a reminder, a method is a function we apply on a what? On a variable. You can either apply it on a variable or on an object or in a value. So this is called a method. So anything that follows with a dot is called a method. That is why you cannot create variables names with what? With dots. Because Python is going to refer it as what? Something referring to a method referring to a particular variable. So sort values allows you to be able to what? Sort values for a particular column. Now the particular column I'm interested in now is what? Total. So I'm going to now say, or let's say the particular column I'm interested in is unit price. Let's sort unit price now in what? Descending order. So I'm going to say unit price. So unit price, then comma, ascending. So this is called what? Arguments. It allows you to be able to what? Give, allows you to be able to what? Set your what? Method. So argument is just like if you have if you like tuning your function. So to suit what you want it to do. So you want to tune this function to suit what you want to do. So normally it has its default values. So let's work with the function with its default values now. Unit price. So you can see now by default now the unit price is in what? Ascending order. So you can see it starts from the what? Lowest. So this means that what? Ascending is equals to what? True. So whatever I will make ascending to be what? False. Because when ascending is false, that means it's going to be in what? Descending order. So I'm going to say ascending is equals to what? False. So when I make ascending to be equals to false, you can see that what? The highest unit price is going to be the what? The top, then followed by what? The lower one, followed by the lower one, up to the what? Lowest one, which is what? 10.03. So this is how you can tune your what? Sort values function. So these are called what? Arguments. They allow you to be able to what? Tune your function to allow you to do what you want to do. By default now, you know it is showing ascending is equals to true. And you don't want it to be showing ascending is equals to true. That means you don't want to be showing an ascending order. You want unit price to be shown in a descending order. So you need to be able to what? You need to tune that function by giving the what? Specific argument, which is ascending is equal to false. When you now do that, then you can now get what you want from this particular function. So now I can also do the same thing also too for the total. So I can just say total ascending is equal to false. So you can see now the highest total is now shown. And when you sort a data set, please always take note, your indexing is going to be changed because it's going to pick the what? It's going to pick that row that have what? The highest total value and make it to be at the top, followed by the next one having the what? Next highest total value, followed by the subsequent ones. So you are going to be having what? Your indexing, you're going to be seeing your indexing is going to be shuffled. So initially now in the data set, we're having what? From 0 serially to 999. But now when you check the ones we have already sorted, we're having from what? 774, you can see, to what? You can see 774, it is what? Scattered. So even our initial first row is hidden somewhere in our data set because it is what? Sorting by the total. So this is how you can sort a data frame. Use this what? Sort values function. So now there is just the same thing we did. It's just that in that other one, I put it in that other examples earlier on. Okay, this is it. So this is it. I did not put it in a square bracket, but you're still going to be getting what? The same answer. I'm just going to be getting the same answer as you get, whether you put it in a square bracket or not. Okay, sorry. Mistake. So you see, it's going to be giving also the same thing. So you keep it in a square bracket, or you not regarding you keep it or you not keep it in a square bracket, you get what? The same thing. Okay, so now if I want to obtain the value counts of all products on that product line. So now you want to get your value count now. So what I mean by value count now is that, okay, you have, let's view our data set once more. So let's view our sales. Okay, so this is our sales now. You can see our sales data sets now. Okay, so now under now product line, you now want to know under product line now how many items fall under miscellaneous, because now currently now we know we have 1,000 transactions. Now I want to know how many transactions fall under miscellaneous, or how many items was bought under miscellaneous, how many transactions fall under braking system, how many transactions fall under suspension and traction. So what do I do? So this is where I'm going to be using the value counts method. So the value counts method allows you to be able to see the number of values under each particular variable or column. So now I'm going to what? Sales product line. So this is my sales product line. This is my sales product line now. I already have my sales product line. So I now want to know the number of transactions under each particular product line. Then I'll now use the value counts function. And so you can now see it now. So under braking system, we have 230 transactions. Under suspension and traction, we have 228 transactions. Under electric system, we have 193 transactions. Under frame and body, we have 166 transactions. Under miscellaneous, 122, and under engine, we have 61. Same thing also applies. What if I want to check now for, let's say, I want to check now for client type now. So I want to know how many transactions made for what under each particular client. You can see now we have what retail to be the highest, having 775 transactions from retailers, then 225 to be from wholesale. I can also do the same thing too for my payments. I'm just going to change this client type to payments. And I also have the same thing. Credit card, most transactions was paid through credit card, 659. Most was followed by what? Transfer, 225. Then few paid for what? By cash. So this is one of the ways which you can know the number of times a particular value occurs. So now currently now we are already knowing how many transactions were made on that product line, how many transactions was made on that payments. So now what if also I want to get the unique values of the column? So imagine I just view this particular data now. You can see this is just the sales.head. And I say that product line, miscellaneous, I'm having miscellaneous, I'm having braking system, I'm having suspension and traction, I'm having frame and body, and I'm also having engine. Now, you can't just assume that these are just all the product lines. These are all the product lines we have. It's possible we can have one product line which is hidden in the middle of our data. So now for us to be able to get the all details of our particular variable, so what you are going to do, you are going to index the particular column that you are interested in, which is product line, then you use the words, you use the unique method. So you can see now it also stores it in a list for you. You can see the square brackets. So it stores it in a list. And this is also an array. This is a data structure also in NumPy. So this is a type of data structure in the NumPy library. So you can this is a list. You can see the square brackets, miscellaneous, braking system, suspension and traction, frame and body, engine, electrical system. So which means that these are all the product lines I have. So anything that you do not see in this place, it means it is not present in your column product line, because this is going to give you the list of all the items. So even if the items appear 5 times, it will give it to you as once. So you can see now we're only having you can see these are the number of product line that we are having. So we are using the unique method to get the number of product line we have. So we can store this now and call it our product line. So product line. I just store this as a variable and call this product line. So you can see it and we can access a product line inside this particular list. So I can just say 3. You can see that also. You can see that now the fourth product line is actually frame and body. So now we just talked about how you can get your value counts, the number of values you have under each particular column. Then also I can get your unique values in each column. So what is your unique values under each column? So let's try unique values for a particular column. Now let's try it for warehouse. Let's know how many, the warehouse is situated in how many regions. So let's try it for the warehouse now. So I'm just going to change this to warehouse. So you can see under where, okay, sorry, this is the length function. Let me remove the length. So you can see we have central, north, and also west. So these are the 3 type of warehouse we have. So this is .unique. You can also get the number of warehouses I have using the length function, which is 3. So it checks to see the number of warehouses I actually have. So now this is also what we did earlier on, also indexing. This you can see now we're indexing our 10, 11. This is actually 11 rows and 2 columns total, and payments. So now the next we'll go to data aggregation. So how do we now get a description of our data? You can actually use the described method to get a description of our data. I can see it here now. This is the describe method. If I'm to run this now, it's going to describe the data set for me. But you should take note of something now. So let me just sales.head. You should take note of something. The describe method only gives you a summary of your numerical values. That is why you're seeing only quantity, unit price, and total covered here. So you're not going to get any details on dates, warehouse, clients type, products line, or payments. So any value that is numeric, you are going to be getting a description on it. You can see the description now. How many are they? 1,000. So if we have a missing value in a particular column now, let's say in unit price, a particular value was missed or it was missing, we're going to be having let's say, for example, one value was missing, we're going to be having 999. So this is going to count the number of available values that you have in that particular column. While we also have mean, so you can see the mean now. The average quantity now was approximately 9.4. Why the average unit price approximately 30.3? Why the average mean here of total is approximately 289.1. So now you can also know your average. You can be able to now explain that, okay, the average unit price of the items that were sold was 30.3. You can also tell someone that, okay, the average total that was made was 299. And here you also have your standard deviation. So this is how much values in this particular column is deviated from the mean. So you can see under quantity now, the standard deviation is 9.7. So which means that the values are deviated from the mean by a value of 9.7. Also have here 12.3, approximately 12.3 for unit price, and also have approximately 345.2 for total. You can also have your minimum value. The minimum quantity that was purchased was 1. The minimum unit price that was purchased was 10.03. That's the minimum unit price of an item was 10.03. And also the minimum total was 10.35. So this is our information you can get. And also have what quartile value. So to have 25% quartile values, 50% quartile value, which is also known as the median class. I also have 75% quartile value. Then we also have the maximum. So now, so this is trying to tell you the value in which was any item above it. So you can see 25% now, 50%. So any item now above 6.5 is what falls in the median class. And also any item above 75% falls in the what? Any item above this value, that is 10.0, falls in the what? 75% upper quartile, that's the third quartile. Same thing too for unit price. Any item above that 7.9. Any item above 37.9 also falls in the third quartile, which is 75% class. Same thing also applies for the total. So these are the quartile classes, and this is the maximum value. So the maximum quantity is 40. The maximum unit price is 66.62, while the maximum total is 2,546. So this saves you a lot of stress using this described, especially if you're having numerical quantities in your data frame. So now that's what we now call a cross tab. So a cross tab allows you to be able to. So let's say now I want to have a cross tab between what warehouse and client type. So now let's see, use the pd.cross tab. So sales, I want to make sales to be on the rows. Then we want to make a warehouse, to be on the rows. They want to make the client type to be on the column. Sorry. So now you can see we have a cross tab. So what we mean by cross tab, you get the intersection between your row and the column. So now this is the number of 371 is the number of transactions that was made in central warehouse from retailers. So how much the number of transactions that were made central warehouse by retailers was 371. Under central warehouse by wholesalers was 109. While under northern warehouse by retailers was 260. So that means we have 371 retailers that bought from the central warehouse. We have 109 wholesalers that bought from the central warehouse. We have 263 retailers that bought from the northern warehouse. We also have 77 wholesalers that bought from the northern warehouse. Same thing also applies. We have 141 retailers that bought from the western warehouse. We have 39 wholesalers that bought from the western warehouse. So now this is an information which means that at the central warehouse, we have the highest amount of retailers at the central warehouse. And also in terms of wholesalers too, so we have the highest amount of wholesalers at the central warehouse. So this can give us an idea that, okay, it is likely that the central warehouse is actually the headquarters or the main warehouse, since majority of the customers usually buy the items from that particular place. While the lowest you can see is in the western warehouse. I can also check for the payment system now. I can check for payments type, that is payments. I can check cross tab for the payments. So you can see under cross tab for the payments now, you can see what I'm having now. Okay, let me change this to client type. So let me see the number of clients that make payments under number of clients that made payments under each particular payment type. So go to the client type. So you can see now that what 116 retailers paid by cash and 659 retailers paid by credit card. And no retailer or none of the retailers paid by transfer. Then also under the wholesalers, you can see none of the wholesalers paid by cash and credit card. and also only 225 of them paid by transfer. So this speaks a lot. This is telling us now that in terms of payment system, the retailers are the ones that pay through credit card the most. So the 659 of them pay through credit card. And none of them pay through transfer. Why the wholesalers, none of them pay through cash and credit card? This is understandable because when you're buying something wholesale, you are going to be spending a lot of money, which you are not going to be carrying cash about or making use of credit card. So you just have to transfer. Why for the retailers, most of what they are buying are not that much. That's the amount of what the amount they're spending is not that much. So the best option for them will mostly be cash and also be credit card. So this is how you can use cross-tab to go to get information between two particular columns. So now we also want to get a subset of the data. So earlier on now we are just subsetting based on rows and columns. Okay, now what if we want to now filter the data by a particular value? So first of all, now let us see our sales. So now if we index this sales by total, now we get all the value of what? We get all the rows under the column total. So what if now we want to see each of this particular column if they are greater than what? 1,000. So you can see now it's going to be returning a Boolean value for each row. So it's going to be going row by row to check if each row is greater than 1,000. Now I can now what? Subset this particular what? I can now what? Filter this particular inside my data frame so that I can get a what? A new data frame. Instead in getting transactions where I just come here and say sales. So I can say sales, square brackets, enter. So you can see now, currently now, you can see from the indexing itself, the indexing is different. We have 5, 8, 46. So though the indexing is going in an ascending order, but some rows are missing. This is because this is a filtered data set. This data set currently now they're looking for, or data frame now is filtering for only what? Total price of items that is greater than 1,000. So total price of items greater than 1,000, this is the resulting data frame you are going to be getting. So you can see it now. It's actually giving me all the values. So you can see it's giving me all the values of items greater than 1,000. So if I only want to get just the top 5 rows, I can use my head method. You can see how I applied my head method on this. So you can see how I applied the head method on this particular filtered data frame. So now what if I also want to apply another condition now, because this is a condition I gave now. Sales total of greater than 1,000 now. I want to now apply another condition now of quantity now greater than what? 30. So sales greater than 1,000 and quantity greater than 30. So I'm just going to put a bracket around this first condition. So the bracket is going to make me separate the condition. I'm now going to be using the AND. You can see the ampersand. Use the AND. Then inside this next bracket now, I'll be giving the next condition, which is what? Sales quantity. Quantity now. You can see sales quantity now. Okay, sorry, it's going to be a quotation mark. Sales quantity now. And one sales quantity of greater than what? 30. So once I want to check for sales quantity greater than 30. So let me remove the head because the results might be small. Okay. So it's actually much. So let me just bring the head back. So you can now see now, this is just the top 5 rows of the filtered data set. So you can see now, all these results now, their sales are greater than 30 and also their total is greater than 1,000. What if I now say greater than or equals to 1,000? So we're going to be including the value of 1,000 because currently now this filtered data set is not including 1,000. I'm going to be saying greater than or equals to 1,000 and greater than or equals to 30. So I'm going to be including 30 in terms of quantity and what 1,000 in terms of total price. So you're going to be seeing now values that are what? If we were to view this particular data now, values greater than 1,000 are going to be included in this, that are 1,000 and also above 1,000 are going to be included in this particular filtered data set. And also values that are 30 in quantity and also greater than 30 will also be included in this particular filtered data set. So this is how we can apply, and this method can be applied multiple times. So currently I can even apply sort values now to this. I can just apply sort values. Sort values. So I want to sort values by, let me just say total. So you can see now I've already applied sort values and I can also apply the head. So this I can make is So you can apply various methods on a particular, just make sure that you're applying the right method on the right data sets, because you can apply a wrong method now on a data frame and you're going to be getting an error. So just make sure that the method you're applying is something that you can make use of on a data frame. So currently now, if you look at this particular cell now, it is checking whether the total is greater than 1,000 and sales warehouse is at the central warehouse. So where transaction was made at the central warehouse and also transaction greater than 1,000. So when you run this is what you're going to be have. So if you check the initial one we did earlier on, we have northern warehouse included, but here we're just going to be having only central warehouse included. Okay, so what if I want to now obtain the total sales that was made in each warehouse? So I want to know how much was made in each warehouse. So that means I have to what? Group each warehouse, and after grouping it, then I'll now get to what? The total. So I'm going to be using sales was grouped by. So I'm going to be grouping by client type. So I'm going to be grouping by client type. Then payments. So then payments. So I've already grouped by client type. So when I run this, what should I be having? So this actually was grouping it for. So what it is going to do is that it's going to group what? Central. It's going to group. First of all, say, let's just group by client type. Let's just start with the client type for now. Let's just go with the client type. So it's going to group the client type first. And now let's apply sum. You can see sum. So sum of the total. We're going to be applying the sum of the total, and we're going to be sorting values. So we're going to be sorting values now of what's total. Sorting values of total, and we're going to be making ascending is equals to false. So you can see what we have now. You can see the sum total under each particular quantity. Now, so you can see it as grouped. So you can see what's our total now. You can see under each particular wholesale. So this was the amount that was made under wholesale. This was the amount that was made under retail. So this I can use. You can see the group by allows us to check for each client type. I can now change this client type now. I can change it now back to product line now. Product line. So how much was made under each particular product line? Total that was made. So this is total that was made under each product line. You can see for suspension and traction, this was the amount that was made. For frame and body, you can see the amount that was made. You can see it. For braking system, this is the amount that was made. And for engine, you can see this is the amount that was made. So what if I now apply also another grouping? I can just apply payments. We want to apply payments now. You can see is first of all, it's going to group for what product line. So under each product line, we now have various payments. You can see most of the people under frame and body, they only conducted transfer. You can see it. While under suspension and traction, most of the transactions were made by transfer and credit card. So we don't have any cash under suspension and traction. While under frame and body, it was only by what? Credit card. You can see it. Under braking system, it was also made by transfer. Under electrical system, it was also made by transfer. So here allows you to be able to know that, okay, under some particular product line, some method of payments were not done. So you can also know, you can see, you can get the total payment that was made under each particular payments method. So this is also using the group by function is a very powerful function that allows you to aggregate your data to get a summary of your data, and also allows you to see if you have some values in a particular variable, if it's under a particular variable. Like now, we know that under frame and body now, none of the clients actually paid by cash or credit card. Under suspension and traction, we also know that none of the clients actually paid by cash. So this you can make news that, okay, a lot of items were actually bought under suspension and traction. A lot of items were also bought under frame and body. And also we can see that you can see also items under frame and body here. You can see cash too. You can see cash. You can see cash for electrical system, also engine. Okay, so now the next thing I'm going to be going now is visualization. How can we now visualize our data? So the important thing to know is that we have a lot of visualization libraries in Python. So we have Matplotlib, we have Seaborn, and we have Plotly, we have Boki. So there are a lot of visualization libraries in Python. But Pandas also has its own visualization functions, allows you to be able to perform quick visualizations. So currently now I want to see my payment system. That's my payments. I want to see my number of transactions. Under my transactions now, the number of transactions that are made under each payment system. I'm going to be using the sales, then I'll pass this to I'll now pass this to my column name, which is payments. Then value counts. So counts how many transactions were made under each payment. Then use the plot method. Then kind is going to be equals to bar. So run this now. So you can see now I'm going to be having a bar plot. So if not for the math plot, so this will have already opened up in a new window. So this will have opened up in the new window. So this is the purpose of keeping it here, keeping that particular code in that place. So now I can see I have a bar chart. So to actually customize the kind of chart you have, I can turn this to a pie. With a pie, you can see I'm having a pie. So let's just leave it as a bar. So as a bar now, I'm able to see the payment system with the highest number of transactions, which is actually what's credit card. So this allows me to see details about my data. So what if I now change these payments now? I change it to warehouse. I can see the warehouse with the highest number of transactions. I can also change this to product line. So you can see now under product line, you can see braking system has the highest number of transactions, almost equals to that of what suspension and traction. So for the group here now, let's run the group also without including the sorts and see. Okay. So under each particular, so I made an error earlier on. Under each particular product line, we have each payment system. So under each particular product line, we have each payment system. Because we included the sort, that was why it was scattered. So you can see by including each. So the first now we are grouping by product line. Second, we're now grouping by payments. Then we'll now get the total payment that was made under each particular payment. So what if I'm to include another group now? Let's call it warehouse. You can see now. So under braking system, then under each payment system, under each product line now, I'll get all the payment system. Then under each payment system, I get what's the warehouse. So this is how we can be able to use the group by function to get what's aggregated values of your columns or of your variables. So what if I also want to get the total sales made from each payment method? You can also use the group by function. So now I can use the sales.group by. So now let me just get for the product line. Let me get the average unit price of each particular product line. So average unit price of each particular product line. Aggregates. P.main and p.plots kind is equals to bar. So you can see now the average. So currently now I'm getting the average unit price of each particular product line. So under each product line now, braking system, you can see now engine are the what's. You can see the engine. So engine are the what's. You can see now we have our legend here, quantity, unit price, and also what's total. So currently now we don't apply it on any particular value. So that is why the legend is showing for the 3 numeric values in our data. So it's actually aggregating for the 3 numeric values in our data set. So you can see now we're having for quantity. You can see for quantity are the ones with the blue values. You can also see the unit price, and can also see what's the total. So now this is the green one, the one we're actually interested in, which is the unit price. So engine have the highest average unit price, followed by frame and body, followed by suspension and traction, followed by miscellaneous, followed by electrical system before miscellaneous, then followed by braking system. So this is how we can actually use pandas visualization functions to view your data set. So this marks the end of our Python data analysis with Python class. So just a quick summary of wrap up what we did today. One, we just introduced the Python for data analysis and also explained variables and comments in Python. So how you can create variables, what variables are, and how to make use of these variables in your Jupyter notebook, and also how you can write comments too also in your Jupyter notebooks. And the two, we talked about the data types and data structures. So having the knowledge of data types and data structures in Python allows you to know the kind of functions or methods you use for a particular variable. So some functions or methods don't just work for any variable. They are only restricted for a particular data type. So that is why you need to know or have the knowledge of data types and structures so that you can know that, okay, for this data type, I can use this. For this data type, I can use it. So in case of a set, yes, I cannot index a set, but I can index a tuple, I can index a list. So if I want to create if I want to store values now, let me use a list or use a tuple, and I'll not use set since I cannot index a set. Those are kind of things that someone needs to put in mind when working with data types. Why today we conducted a case study on motorcycle data sets. So we're able to explore some information from this particular motorcycle data set. And this analysis actually go beyond that or more than that. So some functions are actually beyond the scope of this class, or some libraries are beyond the scope of this class. So this is just a brief exploratory data analysis, how you can use some pandas function to get information in your data. And also I can use pandas visualization library. But normally in the real world, it's not going to be advised or encouraged to use pandas visualization libraries to plot visualizations. We already have specific libraries which are built for that, and they're very interactive, such as the Plotly library. I also have the Seaborn library, which you can now use for plotting statistical visualization. So from me, your instructor, Adejimo Sulaiman, this is going to be the end of our Python for data analysis class.